Welcome back, everyone. We'll continue with our session on the theme Smart Grid. The next talk will be by Ms. Amulya. Amulya is a research scholar at IIT Madras. The title of her talk is AIML AI for Smart Grid Cybersecurity. I invite Amulya onto the stage.
Good afternoon, everyone. I am Amulya, and I am a PhD research scholar with the Electrical Engineering Department. So today I'll be talking about the application of machine learning and AI for cybersecurity in smart grids. So I'll give a brief introduction on the cyber-physical system and the type of data that is available, and then I'll give a brief overview without going into the deep technical details of the machine learning modeling. So as has been already discussed by Dr. Swaroop, the cyber-physical smart grid system consists of a large number of interconnections with the physical devices and the cyber data. And any intrusion into any one of the points in the system can propagate through the system and cause widespread damages to the electrical system, and subsequently it can also lead to damages to other systems, since most of the systems are related to the electricity, which is why cybersecurity becomes a very important issue. The attacks can be of different types. There can be physical attacks, which is directly impacting the sensors and the measuring units. There can be attacks on the communication channels, and there can also be attacks at the control centers where the data manipulation or the data analysis takes place. The special thing that is to be noticed here is that while most of the talks that we heard today, there were dedicated instruments that had to be installed in order to get the data and then do the processing. But when we consider the smart grid cyber-physical system, there are already a large number of measuring units like the remote terminal units, the phasor measurement units, etc., which give out data at the rate of even 120 data samples per second. So there is a huge amount of data that is available with us, and proper utilization of this data can be done in order to implement many algorithms, which also includes the cybersecurity algorithms. However, when we consider the smart grid data, we can see that the type of data that is available is varied. We have the sinusoidal data relating to currents and voltages. We have different other data like the frequency, the renewable energy data, etc., which can take nonlinear shapes. And then we have the load data. And in addition to all of these, we have the packet level data, that is the data that is transmitted through the system. And even these packets are not always just the TCP/IP based packets. There are a large number of protocols that are associated, and each of these protocol data has a different type of structure. So what we see here is that a single type of algorithm or a single type of data processing will not be sufficient when we consider the smart grid data, which is why the process of machine learning modeling for attack detection in power system depends on data processing, model training, and then we move on to the detection stage. When we consider data processing, there are different types of data, as I have already discussed. So when we consider the voltage, current, frequency, that is the power related data, mostly the pre-processing is done using signal processing techniques like fast Fourier transforms or density based analysis, etc. While on the other hand, when we consider the data related to the packets, that is analyzing the IP, the MAC address, or the protocol specific data, we usually use machine learning methods itself even for data pre-processing. So the data pre-processing is one of the most important steps when it comes to machine learning in smart grid systems. The next thing here is the model training. One important thing to be noted is that though we have a large amount of data available for the power system, the attack data is very sparse. Since it is a national security issue, even if there are attacks onto the cybersecurity, into the cyber-physical power systems, the data is usually not given out, which is why the attack data is usually not available, and so we have to make use of the normal data in order to do the attack detection, which is why the unsupervised or semi-supervised learning algorithms are given more importance while designing the attack detection process. In addition to that, when we consider the training, the power system is always keeping on changing. There are new additions into the system. There are sometimes the lines might go out, and there might be reconfigurations in the system, which is why online training that is based on reinforcement learning can play a major role while doing the while implementing machine learning algorithms. Sorry. Finally, when it comes to the detection process, detection is only one part of the cybersecurity analysis. Once the attacks are detected in the system, there are many steps waiting to come. That is, the mitigation is also very important, because the system should come back to its normal state so that all the systems interconnected to it functions properly. So the detection algorithm should be very fast, and the speed is of utmost importance in the detection process. And as I have already told, adaptivity is also very important, since the system keeps changing every now and then. We'll now look at a machine learning method called as the ensemble learning, which is implemented for attack detection. In ensemble learning, there are multiple machine learning algorithms and different data sets. That is, as we have seen, there are different types of data sets available. So different samples are created, and each of this sample is fed into independent classifiers which operate independent to each other, and the result of each classifier is then combined using a combiner algorithm to give the final predictions. Now this combination can happen in different ways. In attack detection process, it is important that the attacks are detected correctly. So the classification of the attack is given importance, and based on that, the combination is considered. Now here we have a system. So as we see here, here we have considered a 24-bus system for the smart grid, and the data from different nodes is being sent to a central controller, where which constitutes the cyber layer, and where the different processing takes place to implement stability issues, to deal with market issues, etc. If there are certain nodes that are being attacked, and when this data goes into the central controller, the decisions taken by the central controller are wrong, which is why we need to detect these attacks fast. So for ensemble learning, the base classifiers that we have used here is the support vector machine, the random forest classifier, the k nearest neighbor, decision tree classifier, stochastic gradient descent, and neural networks. So those who have been working with machine learning might know that all of these algorithms have different types of properties, and each of this brings with it its own advantages, which is why when we combine all of these algorithms together, we can different advantages can be embedded into a single detection process. For example, if we look at the results, let us consider a support vector machine based classification. So here we have 3 classes, which is the normal, the contingency, and the attack. Normal is the usual power system operation that takes place. When we consider contingency condition is that when, for example, a line in your system just goes out, then what? So these kind of things are similar to what an attacker can induce in the system. So the data pertaining to the contingency class and the attack class are mostly similar, which is why most of the algorithms do not differentiate between the contingency and attack classes correctly. As we see, the random forest also does not classify the contingency and attack classes properly. However, when we combine these two and the other algorithms together to form the ensemble learning, we see that the classification accuracy is very high, and even the contingency and attack classes have been classified with a high amount of accuracy. Thus, we see that the machine learning algorithms have a huge scope when it comes to attack detection process and cybersecurity in power system in general. And the ensemble learning can be further improved in order to include even more data, that is different types of data, like even the IoT based data that is coming up from different entities can also be included, and the overall detection accuracy can be improved. Also, when we consider mitigation strategies, the expert systems, the artificial intelligence, etc., can also be included in the algorithms, so that the machine learning can be extended to even the mitigation process. I have not gone into the technical details of how the data is extracted and what are the exact parameters of the algorithms. These can be found in the above references. And if you have any other clarifications, you can always contact me. Thank you. If there are any discussions, then yeah.
Hi.
Hi.
Can you hear me?
Yes, yes.
Okay. Just one question. So how your system works is it's a combination of multiple classifiers, right?
Yes.
Ensembled into one.
Mm-hmm.
Okay. Can you just talk about how the weighting is done?
Pardon?
As in, I'm assuming there's some sort of voting, right,
Yeah,
on
yeah.
your different classifiers?
Yeah. So the voting, the strategy that we have used, mostly it is the majority voting that is usually used.
Okay.
But in the considered algorithm, what we have used is that the tuning parameter is n, which is the number of algorithms which say that there is an attack. So this parameter is what is tuned in the ensemble learning. That is, if out of say 10 classifiers, if the parameter n is tuned such that, say, if 3 classifiers say that there is an attack, then we consider that there is an attack. So that n parameter is where the tuning occurs.
Okay, so it's just on majority voting
then? It's
then?
not majority voting.
Oh,
the
sorry.
Emphasis is given on those algorithms that have predicted that there is an attack.
Oh, okay.
Because the attack is an important.
Fine. Okay, thank you.
So I had a question. When you say it's an attack, right? How do you know it's an attack? Is there a signal which is changing?
Yeah. So what we have considered is that the attacker has already entered into the system and has started causing changes in the system. So it is important that these attacks are detected very fast. So when there are changes in the system, so it can be that the signal is changing. So the actual frequency should have been say 50 Hertz or in the range of 50 to 52, but it might increase, or the pattern itself might be different. And there are packets. And when we consider the power system, the smart grid packets, they follow a certain pattern. That is, there is a certain pattern to that, and using those values within that packet also, we can analyze those packets and say that there is an attack. So these are the different types of signals that we have in the power system.
Could there then be any false, positives, in some reason there is some fluctuation?
Yes, exactly. So that is what I was discussing about the contingency state. So yeah, in there, under contingency, it could be a contingency or it could be an attack. The same type of effect is caused when there is a contingency and an attack. So this classification is what needs to be given more importance now.
So how does it then differentiate between a contingency and actual attack?
Yeah, the difference is one, which is where the combination of signals and packet analysis comes in. So when we combine these two, we can know that if this particular signal changes in this way, some other signal at some other point should also have changed this way. So either the attacker should be very highly skilled that he has to change all these parameters, or it is based on the correlations, we can determine that there has been an attack.
Thanks.
Thank you for the talk, Amulya. I invite Professor Balaraman Ravindran onto the stage to hand over a memento to the speaker. With that talk, we come to the end of the session on Smart Grid. We now have a panel discussion on the role of AI and data science in realizing the vision for smart cities. We're very fortunate to have panelists with diverse backgrounds. Please get your hands together for our panelists. Mr. Raj Cherubal, he's the CEO of Chennai Smart City Limited. Our speaker from earlier today, Dr. Vijay Kovvali, Professor of Practice from IIT Delhi. Professor Gitakrishnan Ramadurai, he is an Associate Professor in the Department of Civil Engineering, IIT Madras. And our moderator. Professor Sridharakumar Narasimhan, he is a professor in the Department of Chemical Engineering, IIT Madras. Professor Ramakrishna Pasumarthy, he is an Associate Professor in the Department of Electrical Engineering, IIT Madras. The floor is all yours, sir.
As part of the panelist, then I realized I'm better asking questions than answering. So I became a moderator and Dr. Vijay Kovvali graciously agreed to be a panelist. So what we're going to do, the pattern for the discussion is give the mic to each of the panelists first. They can have some opening thoughts, right? With 3 to 5 minutes they can take. They can share what their thoughts are in terms of what is the role of in data science in smart cities. Right? Interesting thing is we have people from different backgrounds, transport, water, as well as power. So I guess we'll get to hear David's thoughts. Then we have a few questions, for some of them. And we also have an audience around where the audience can also pose questions, they can have their comments, right? And then we can have some responses. So I will go in the same order maybe. We will start with Raj.
Thank you so much. I think since we had a lot of technical stuff in the morning, I'll just take a very different approach because after all, we're trying to solve real problems. So the question for me is not AI, machine language, blockchain, cloud versus computer, Fox Pro, Excel spreadsheet. All that is secondary, right? What problem are we trying to solve? See, if even if every we're talking about smart city, and forget the word smart city, right? It's any city, any state, any country. Imagine in Chennai, every department and every person is a platinum level, Singapore level department, right? I suspect that we'll still have a human coordination problem. And this gets even worse when each department and the capability of people and systems are very, very, how do I put it politely, developing country level. Okay, that's a very polite way of putting it. So, so that's one problem we have. How does AI solve that? Second problem is we don't have 100 years like Hong Kong or Singapore or London, Paris had, where you can build systems, make mistakes, keep iterating, and make it into a Paris or whatever. We can't sit back and tell everybody that, hey, give us 100 years and a lot of money and we'll do AI or somehow we'll solve your problem. So the question becomes, how do we leapfrog? So a simple, quickly example would be when I'm of a generation where I used to remember the rotary phone. You had to beg, borrow, steal, lie and cheat to get a phone. And today we have leapfrogged to everybody has a phone and most people have a smartphone, etc., etc. And even before you think, the phone is telling you what you're supposed to do. Netflix tells me what I'm supposed to watch, and so on, right? So I look at governance. We are at the rotary level, rotary phone level, right? So I'm sure we can leapfrog to a better system. But then again, like I said, we don't have infinite money. We have very limited capacity. We can't even figure out what the problems are actually, what to solve, and so on. So my way of looking at it is 80-20 rule, right? So how do, with a very limited capacity, how do you look at 80% of the problem that is most important to any given vertical, and with just 20% effort, can you solve those problems? Okay, that's one problem. The third point is, I know for sure in Chennai, we have mega projects happening, right? Multi-million-dollar projects, which were unthinkable a few years ago. We'll be we're already drowning in data. With Vijay and I have been working on a project, like a gigantic project. Like that alone, just one project will be drowning us in data. You won't even figure out how to use that data, given data, let alone n number of other projects that's happening. This is where, again, machine language or whatever is going to come in, right? So the question, and the other problem is that you have academics, and I saw a lot of things, amazing stuff happening here. Then you have L&Ts of the world, the companies who do these kinds of things, right? You ask them to do ABC, they'll do ABC. You ask them to do XYZ, they'll do XYZ. But as a client in governance, I need to know, or whoever is on this side has to know what is the problem you're trying to solve, right? So if I ask you for this, like Apple, right? Apple's philosophy is that you don't know what you want, we will give you stuff, right? That's an arrogant way of looking at it, but how do you do that in governance? So if you ask, I know I need this, I'm sure somebody can deliver this, but this is not what I really need, right? So so what is the use case you're trying to solve? Do you, the academic, do you, the system integrator, know what is the governance, smart city use case that you're trying to solve? I doubt you know, right? So simple example. I always challenge people in every seminar forever. Commissioner of the city walks in and says, look, we have very limited money. Tell me the top 100 potholes I'm supposed to fix today. What mechanism would you use to figure out those potholes? Is it the potholes that are creating most malnourishment in the society? Or is it causing the most flooding? Is it causing the most violent accidents? What is the criteria? That itself we have difficulty figuring out what to do. Let alone if you start getting the water analytics, IoT device, etc. into it, and then you start analyzing to ask yourself, how do you predict which child is going to drop out tomorrow from school? Which child is going to get a disease that will make that child's life difficult for the rest of his or her life, right? And so on and so forth. So what I was just talking to Sam, this is not a greenfield problem. The question, if in a nutshell, the problem statement is, how do you create value out of chaos? How do you stand in the middle of total chaos, make sense of it, and figure out how to solve the most important problems first, then the second problems and third problems and so on, so that we can actually leapfrog to catch up with a Hong Kong or a London or a Paris. I'm optimistic, so I can see that we'll get there, like the smartphone, but it's not going to be easy because the clients and the suppliers and the academics, nobody seem to know what exactly are we trying to solve, or we are solving it in silos, right? We don't have the capacity yet to leapfrog. Last few points quickly. There's a practical problem out there. So for example, in Chennai, as we speak, there are about 600 edge analytics cameras. 6 years ago, when we talked about edge analytics camera, people used to laugh at us. He was fantasizing about some nonsense. People couldn't imagine that a camera could actually be trained in machine language and so on to figure out. So for example, if a subway floods, we get alerts. Our edge analytic camera can tell you that it's flooding, right? A garbage bin is overflowing, we can figure it out, and so on and so forth, right? We have a bunch of IoT devices, we got all kinds of pollution sensor, etc. So my thing to my team always is that you don't have to tell me it's raining. I can put my head out and tell you that it's raining. You don't need a cloud and IoT device to do this, right? You know it's polluted. Any Indian city is polluted. You don't need a pollution sensor, expensive pollution sensor to say so. So the question is, okay, that's one thing. The problem is that each systems exist in pieces. There is no market mechanism to figure out, somebody will say open source, right? But then somebody has to sit and type away in Python or JavaScript or whatever to connect this with that, to that, to that. And that's going to take 10,000 years to do. So there's no mechanism to say, hey, this is my use case. Machine figures out where to go grab what and tell me a pattern. It doesn't have to be precise. So we shouldn't chase precision. We're not there yet. Approximately tell us which pothole. Approximately tell us which tree is going to fall tomorrow. Approximately tell us which child is going to have some disease and so on and so forth. It's very difficult because we have all these systems sitting around in different things. Sometimes that's why I said Fox Pro, Excel spreadsheet. The data is sometimes sitting in those formats, all the way to IoT device and whatnot. The question is, what is that mechanism by which we can, without sitting and doing a big project management from here to eternity, and trying to figure out these use cases and patterns. So I'll stop at that. That's where at least my frustrations and my life comes from. Thank you.
Thank you. So I have actually a number of questions about that. So I think you've already raised it. Okay, we'll discuss more. I think Dr. Vijay, you want to share your thoughts?
So I just want to know how many of you are civil engineers, transportation background here? You can lift your hand. Okay. So historically, if you see the ITS there, Intelligent Transport Systems engineers are all civil engineers with transportation background and people who never did technology before that. And the reason for that and the reason US and North America, the European countries are all successful implementing technology is because it's led by transportation people, right? And the reason is also we are not concerned about whether it's like the way Raj is saying, we're not concerned what the hardware and the software is. We are concerned about the functionality of it, right? The operations, what is it that you need? So even when you talk about MI, AL, any of these things, the basic thing that you need to, and if you see my BA presentation in the morning also is, what are you trying to achieve? What is the needs of the people? What are the audience that you're looking at? Very often, most of our technology problems have projects have problems because we do technology for technology's sake. So while Raj is talking about 600 cameras, you go and look at what are they doing with that data. And you'll find out like sometime back in Bangalore, they said we have 2,000 cameras in the city. I go to their control room, less than 100 are working. Why? Because they don't have power, they don't have communication, right? So, and when we were doing, like I moved to India in 2007, and when we were doing one of our first projects was Mysore, we put CAD AVL systems, basically automatic GPS units on buses, okay? 2010, 2011, that time. And one of the big challenges I had is basically the input for whatever bus schedule has to happen, they were doing it in a book, and then they had to enter again in our system, and they were not happy about it. So they said, why should I enter it twice? So the next project I did, we put it in saying that, okay, that entry also needs to come if the integration has to happen. And if you look at the Hubli-Dharwad project, we have a 100+ crore project, okay? And when it comes to Bhubaneswar, 780 crore project, because we were integrating systems and systems. Chennai ATS will be around the same range, okay? What you realize is that there is no right answer, because when you integrate a lot, that also creates bigger challenges. But if you don't integrate, you work in silos, right? What we need to do is we need to find solutions that work to this whole systems, right? And there are no easy solutions. Like nobody can tell you this will work or this not work, because and there is a human factor that comes into picture that also has an impact. But the point I'm trying to make here is that when you're thinking about any machine learning, any AI and stuff like that, the basic things are the things that really matter. Like, and you need to always think about the functionality, and you need to say, hey, what is it that I'm trying to achieve? And am I achieving that or not, right? What I really felt in Mysore that we achieved more than the technology itself is we helped them with their governance. After that, they knew how many people were there, what their drivers were doing, all those things that should basically happen, right? In other countries, planning is always a given. Technology is improving because you find problems and you're trying to solve the problems. In India, we see that planning is where like technology is using us to basically figure out the base problems that we have, and we are trying to solve them over and over. But if you see the curve that we are going through, we are going slow, but slow is sustainable, right? And I just want to conclude with saying that our final objective is always livability, okay? It is not about building, like I saw the Faridabad smart city that L&T was showing. Pedestrians can't cross the road. Cities are for people, okay? Please remember that, okay? Whatever technology you do, whatever you're doing, cities are for people. It is the human being that is at the center of it. And you need to remember that all through. If I ask my son, like my son used to say that, I don't want anybody to cut trees. I said, for one life, how many trees will you cut? And he said, 10 trees. I said, my life, how many trees will you cut? And he's willing to cut all the trees in the world, right? And that's the reality. You need to personalize it, and you need to look at it from the person, and then you think differently about it. And especially the technologies, I wanted to think like that, because most of our problems are technology. People think very technology oriented and don't think what they're trying to solve, okay, from an operations perspective. Yeah.
Thanks, Vijay. So, perspectives on water, but of course, you don't have to restrict to water, right? You can flow into other areas.
Smart mic. So we definitely need smart mics. This is on already. Okay. So smart mics which figure out that it's time for somebody to speak and turns on. So I'll be taking a more academic and perspective. So all my life I was a theoretician. I know the last several years, thanks to several of my colleagues and so on, got into working not just with complete theoretical or simulation projects, but also doing things on the field. So one of the first things I'll take a slightly different view over here, and they talked about surfeit of data, especially in the water sector. My experience has been that the data is, a lot of data is lacking, especially physical data, but physical infrastructure is lacking. So you may not have up-to-date water maps. Rohit, who talked in the before lunch, he gave a illustration of the pump system in the ICSR. So this was a plumber who was working here, switching the tanks on and off daily for the last several years. And he claimed that, he showed one tank, he claimed that the pump over here actually fills 2 tanks. And he was confident about it. So we put the sensors, and then we found that the level in one of the tanks doesn't rise even though there's filling. So that obviously means that tank is not connected to this line. It's getting filled from somewhere else, God knows where. But the fact is that when you put these sensors, this is a trivial problem that you could solve, because there's one line, one sensor, and a couple of sensors. The pump is running, the tank is not filled. One of the tanks is not filling, so obviously that tank is not connected to this. The more difficult problem is who's filling that tank. So how do you solve these kinds of problems? So hopefully, hopefully there are smart ways of solving this, and that's some of the things which we are working on. A shameless plug for what we are doing. The second is again talking about the 80-20 rule, right? So how do we, and again, Vijay Sai mentioned it in the morning. You can't obviously, a lot of people have pretty much skeptically given up on trying to measure and meter every consumer. I think there's a lot of skepticism that it will ever work. So do you want to measure every consumer, or do you want to spend your efforts on the 80% of the people who matter? Likewise, do you want to identify every leak? Or do you want to spend the time, like Raj mentioned about the potholes, the major leaks? If you assume that every pipe is leaking, then again, maybe it's a good thing, because I read somewhere several years ago that Bangalore water table actually went up, and that was attributed to leaking pipes. Okay, so that thought I'll conclude and hand over the mic and probable baton to Ram.
Okay, I don't know which view I should take, academic or more application or even more political, because so I was looking at some pictures from Bangalore this morning, and it looks everything else but a smart city, right? Like a couple of hours of rain and everything is flooded. I was in Madurai for the weekend, it rains for 5 minutes, the power is gone, roads are flooded, Ola, Uber switch their things off, and you have to pay 3 times. In fact, the auto wala was apologetic when I went from place A to place B. He said, sir, normally we take 60 rupees, today it's raining, so I'm taking 100 rupees. So that's where we start, and then I wouldn't know what will be the good confluence. Maybe the practitioners can say a little better of the existing urban infrastructure problems, where even, say, in Chennai, in peak summer, you see a lot of voltage fluctuations. You still see sometimes power outages. You still see, of course, I don't need to mention about traffic. So all from academics, we kind of live in a very ideal world. We assume things will work. So I come from a controls background, and all we do is, as Sridhar was mentioning, we spend all of our life doing theory with extremely realistic assumptions. We formulate problem with a lot of assumptions which we know that will give us a. For example, I just say, okay, I want to go from, say, Chennai to Delhi in 1 hour in a car. Theoretically, it might be possible, but practically, I may not be able to design such a car. Now, the gap between the existing drawbacks or maybe lack of infrastructure and this illusion that AI and ML, I mean, it's also with students, right? A lot of people come to me and say, look, I know AI and ML, and let's do so and so problems. Like all the problems you do are outdated and all, which is might be true. But so my caveat here would be that okay, that the smart city might itself, I mean, if you go to cities that were talked about of London and Paris or Hong Kong, you sat at a station, you still see the arrival times of the next buses. It's not even metro trains, right? And this were not like, maybe for us this would classify as smart cities, but this didn't need like extravagant or very sophisticated AI or ML algorithms. I think the step towards smart cities would just be to get the basics right, or spend a little more time on planning or replanning, and then to get hope or illusion that I pump in 100 crores in, invest in AI and ML and the city wouldn't be smart. That's a little far-fetched. So I would still go one step down and, look at basic, say, modeling problems or basic optimization problems. I mean, the word intelligent transportation system existed much before AI and ML became, more like a household name. So I would really focus, take 2 steps back. There are things talked about health of transformers, digital twins and all. So I think there are a lot of things which we should do, keeping physics or keeping the dynamics or models in mind. Of course, therefore I say, okay, it's a good for us to also assume an idealistic scenario and carry out our research, but also for the other end also to not assume that the solution to everything lies in AI ML. It's possibly a good combination of both of these worlds, and especially for students or young researchers who think in that direction.
Thank you. So it's a rather grim note for a conference on AI. Don't work on AI.
Why should everybody be supportive of?
All right. Devil's advocate. All right. So, Raj was mentioning about what is the problem you're solving, right? So I was wondering, has there been any needs assessment done on what users want, right? Whether it be mobility, water, power, right, for smart cities. What are exactly, the problems or the needs of the users? Is there some study that people are doing beforehand, any thoughts on that?
So I think I can speak for Chennai. I don't know about other cities. We are living in the golden age of needs assessment. There's never been in Chennai's history so much needs assessment is being done. I'm being serious. I'm not joking. CMD is, as we speak, doing 3rd master plan, and hopefully because of World Bank involvement and some of the officials are very good. Hopefully this will be one of the very good, proper master plan, not simply looking from the moon and saying Chennai will be a great place. Actual this thing, right? I can spend a half an hour just rattling off projects that's happening in Chennai. So for example, the ITS project we talked about, it's 497 junctions have been studied in the CMA area in every aspect. If this project doesn't solve traffic problem, we might as well close the city and move to Bangalore, I suppose. Okay. There is a gigantic accident reduction. Chennai, by the way, is one of the capitals of accidents in the world, right? So our objective is in 5 years, we should cut back accident by 50%. That's a massive study. There's a mobility resilience that says, okay, when it rains or tsunami or whatever, how do you keep the transportation system resilient? So there are n number of projects that's happening, right? And these are serious consultants doing serious data collection. That's what I meant. We are actually in a golden age of as far as needs assessment is concerned. Similarly, Metro Waters, there's a gigantic study going on in terms of water management and so on. So I think on a positive note, we should be leveraging on all this, right? So one of the attempts we're trying to make is put all this data into a GIS system so that anybody can go look at it. You don't have to know me or him to go figure out what's in the database, right? That's a first step toward doing something. We have something called the integrated command and control center. If you come there, it looks like a NASA center. It looks beautiful. But every official, after 2 seconds, he says, now what? You have IoT device, it says, okay, it's polluted in near IIT or something. Rain, it says raining in Alwarpet. So the commissioner will say, what am I supposed to do with this, right? This is where I think students and professors and others can come in and say, okay, you know what is it that the city is trying to do, even with all these different studies? Each study will solve its problem, by the way, right? If you simply implement the accident study, road safety study, it'll save lots of life, and that is good enough as a city. But can we leverage on all these different pieces and then try to help master planning, etc., become more dynamic, not a static, once in a lifetime study, so that every day you are master planning, right? Things change. I mean, people change. Malls come up here and there. A lot of unplanned things happen and so on. So how do you make master planning and life and also, see, you can't stop a city just at a master plan level, right? So if you go ask an engineer on the road, he's not interested in master plan. He wants to know in the lamppost, right? Advanced city will look at the water flow, the wind pattern, and solar energy, this, that, and all, and they'll say, look, don't put it here, put it here, right? For us, we don't have that kind of mechanism, right? So we need to go to that level that says, look, it's not simply about a lamppost. It's about n number of other parameters that need to be looked into, and so on. The last bit I'll say is that just when we were trying to figure out how to put a footpath, the world is now talking about climate change. Just when we started figuring out how to dig a road properly, people are talking about resilience. If I ask you what is resilience, what is climate change, I doubt if anybody can give you a proper answer, right? So again, the system is getting even more complicated. It's no longer good enough to simply put a footpath or a bus or a lamppost. You have to be able to say, you know what, is there a circular economy going? Thoothukkudi's wind power has to run that bus when there is peak hour and pump the water up so that you can store energy on top and release it and so on, right? I don't think any human brain is capable of doing all this stuff. This is where machine language and etc. all these is going to come in, where current system cannot handle any of this stuff. Even in a silo, we can't handle it. So we better figure out how do we leapfrog using AI, only because we are not able to figure out as individuals, even as systems you're not able to figure out. So you need machine language, some kind of machine and system thinking to be able to leapfrog and say, you know what, don't put the lamppost here, put it here, because we looked at child nutrition or women's safety data and we realized not here, too there, right? So I think we need to get there soon. I don't know how we're going to get there. We may have to, again, slice it into pieces and say, okay, just road safety and ITS, just water and this thing, just stormwater and something. And then maybe start putting bigger and bigger pieces together. This is something IIT should take up, because this is a problem where we talk once a year. I meet him once a year, we have the same conversation, but I think you guys need to seriously start taking that data that we have, cut into pieces, solve pieces strategically and assemble it strategically. So maybe we can set an example for the world.
We'll come back to the audience. Other thoughts?
I just want to add what Raj has said. I know the negativity on the AI and ML, because most of the time that's what we deal with, right? We are trying to solve the big problems and the basis doesn't exist. But one of the things is about 6-7 years back, I didn't believe in electric energy, EV vehicles and all that. The reason is the back grid is all like still more polluted, right? So you have the same fossil fuel plants and everything. So what's the point of putting electric vehicle? And in Facebook, we were having this argument, like a few of us believe that as long as the backend is there, what's the point of selling EV so much? But somebody made this beautiful point saying that, see, the backend can change very fast, okay? You can take away fossil fuel plant and put a thermal plant or a solar plant or something like that. But each of these individual vehicles, changing them takes forever, okay? So cleaning the grid comes really fast. And that's the same thought process we have, okay? We know that at the base level, our foundations are weak. Our big problem is our foundations are weak. And some of the things that I badly want to work on are the standards and codes so that we create our foundations that are stronger, okay? But once we have that, we still can't say that until that is fixed, the rest cannot be fixed. And that is where you all come in and the AI and ML comes into picture. We are doing all the things that are required, assuming that this foundation will get fixed at some point of time. And at least I'm sure Raj and I believe the reason we keep working in this is it will happen in the next 5 years or so, okay? We are going to have, we will have better designs, better drawings, better understanding of all our base layers. And then at that point of time, we will have all the research that we have done in the other academic world and other places to leapfrog everybody, okay? And that should be our objective, okay? We should be #1 in the world, we should be a developed country. And the only way to get there is not to try to fix the foundations forever, but use all the technology and everything, all the latest innovations to get there.
Any other thoughts regarding user needs?
Yeah, I'm just thinking, okay, I'm not being critical of AIML, I'm just advising some caution here. So for example, some problems that we think of that, things will shift from, say, everybody will have a EV. Then what could be the consequent problems of that is everybody needs charging. And now if you look at the fluctuations in Chennai in summer, you really see a big drop of voltage essentially because a lot of people turn on their ACs maybe at 8 PM or things like that. So what would be the effect on the grid? And possibly we don't, a student will say, sir, give me some training data or, let's do the data for a year and then see, we'll then build models for, grid stability and all. But possibly that may not work because the system may not have appetite to just collect data, then the grid will trip and all that for a year. So this is where I think some of those intuition-based or some maybe a small setup can go to a larger scale. And there are problems for which we may need a little more anticipation than just going the traditional way of implementing algorithms. And so and therefore here also a lot of players need to come together and then make decisions here. And of course, whenever there is data, and a lot of times we collect data without context, right? So how do you contextualize the data? How do you therefore say, okay, under some constraints I do this way, and some other context I do this way, and so on. So okay, I'm not a opponent of AIML, but I would just say to be a little more cautious that it doesn't possibly, according to me, solve all the problems.
Sridhar?
Another thing maybe we should look at is how to harness the power of crowds, right? I mean, we seem to be very good at crowdsourced information. For instance, this is a very purely anecdotal. There is a bus stop just before Madhya Kailash. 14 years ago, I was waiting there for half an hour, and before somebody told me only the structure exists, no buses stop there. Likewise, if you're coming from Adyar to here, just opposite Adyar bus stand, there are 2 bus stops, and there are 2 different sets of buses stop there. And nobody has bothered to put up, even now, I think, a board which says which bus stops where. People know about it. People seem to know about it. Right? There's no protest saying that I don't know, I didn't know. Nobody seems to be pick up a fight with the MTC conductor or driver saying, why did you not stop there and why did you stop here? So that's maybe we should harness the power of crowds, because they seem to be happy and people have figured out where to stop, where to wait for the which bus.
Okay, so expectations. There was one point that our chief guest made today morning about maintenance, right? So he said that we implement all these systems, but then either we don't budget for maintenance or we don't have the manpower or the knowledge among our employees how to maintain these systems, right? Are we going to have this problem more, right? Basically invest tens of thousands of crores across the country, set up these systems, and then 2 years, 3 years down the line, once things don't work, we have these white elephants, what do we do with it, right? Is there some thought on this, how we going to handle maintenance? And
to answer your question, like one of the things people keep coming and telling me is smart cities are a failure. Okay, very common thing I keep hearing. Anybody who's not part of the system says that whatever is happening is a failure. Okay, that's a reality that we go through. I know everybody who's not in a bus says bus system is a failure. Everybody who's not in a BRT will say BRT is a failure. So this is a given. Okay, but when you look at it, right, in Bhubaneswar, for instance, we did the smart city project. We spent about 1,000 crores on the smart city. Okay, and I was just looking at the evaluation, and I'm saying that okay, is it a failure? Okay, assume that none of this technology works. It worked for 3 years and it goes away. Okay. Even when you look at it and you say that within the 3 years it saved about 5 lives, okay, because of whatever, somebody went to the hospital faster or something like that, and about at least 500 people got more capacity than what they had, especially in government. Creating capacity is only through working on it. Okay, so when you look at these systems and you say, okay, how much money am I willing to spend to train 500 people who are going to be in the government for the next 20 years, 25 years? And you look at the benefit cost of that, okay? However you look at the benefit cost, it makes sense. One of the big challenges that is there in government is we have money for capital cost, we don't have money for maintenance, okay? At my previous company, IBA Group, we worked quite a bit in North America also, like we were working with North American clients. We had a smart city platform that we were trying to sell in US, India, Mexico, like Latin America. None of our products would sell in US because they never had money. They don't have these huge chunks of 700 crores, 500 crores money that we are talking about like this, right? We are spending so much more money that North American governments don't spend that kind of money, okay? What we need to do is we need to do a better job of creating this, right? Creating a strategic plan in terms of the way we deal with maintenance today is we hire a system integrator for 5 years, okay? So for 5 years, it gets maintained. Once he goes away, it goes away. But for 5 years and another 1 or 2 years, where we have a gap is the government taking over and making it their own, right? And if you look at, and one of the big challenges when we write specifications for international vendors is, we say O&M for 2 years. And none of the international system integrators have done O&M at all because they have 1 year and the government takes over, okay? The agency takes over. We need to create those systems where the agency has the capacity and the will to take over. And we need to have incentives for this government employees to take over this. And that's a different set of problem. It is not a technology problem, it is more a governance problem. And Raj has been dealing with governance a lot, so I'll give it to him. Let's see if he has answer.
I can say that increasing, see, I'm a lot more patient man when it comes to these topics, right? See, you can't go from 0 to 100 overnight. I know it sounds very, elitist and saying 100-year plan and all. I don't mean that way. I'm a student of physics, by the way, okay? So I look at things as a complex system. You can't extract simplicity out of a super duper complicated system, even if you wish, right? So when I'm not exaggerating when I say we have difficulty figuring out how to design a footpath. I'm not exaggerating. And that doesn't mean we are all stupid people or something. It's a systemic problem, right? Because like you said, standards. You can buy IoT device, you can give them some money, you can go to the market and buy IoT device. But a Singapore or a London or Paris or Tokyo is what it is because of n number of other unglamorous, boring stuff. Manuals, specifications, and so on and so forth. From footpath all the way to IoT device, you can't simply use your brain and say, today I feel like doing this, right? I don't think anybody in advanced city can, just because somebody told in the public, it doesn't work that way. They all standardized and so on. But they took them 50, 60 years of mess and learning and systems and so on. That even if we had that kind of a system, it will take, let's say, 10, 20 years. That's number one. Problem with our system is that we have a very chaotic system for 200 years, let's say, right from British times. So the city never had the capacity to build capacity, even from a simple, and forget IoT device and all that, even for basic stuff, there's no expertise because people keep rotating, right? Today you're in stormwater drain, tomorrow you're in water, next day you're a tree expert. You keep rotating, which means you never gather the expertise, and the system and the department, the office, etc. doesn't gather expertise to be able to make those strategic long-term decisions. Imagine IIT. If a computer science professor suddenly moves to biology, next day he's moved to water department or something, who will come and study in IIT? Nobody will come here, right? This is what happening in every city level. So see, because it's a machine language, AI conference, we're talking about it. But AI cannot solve stupidity of the system, right? I mean, it takes a lot more processes and policies and procedures to be able to solve the basic problems. So I'm not saying AI will jump in and solve all our 200 years, 500 years of craziness just because you turned on the AI. But AI, where AI will make a difference, and instead of using the word AI, I think we should just simply say data. See, right now the last 10 years trend is to say make policy based on data, right? Don't just randomly, just because you went in a car and you thought through some policy, don't make policy. Where is the data, data-based evidence, and so on and so forth. So look at AI only as a layer on top of the data, and not as a special something happening. When the data gets so huge and so complicated and so diverse and disparate, human brain cannot make patterns out of it. So yes, okay, use AI. But still, all we are saying is use data to create policy, data to create, decide what to do, data to decide where to put the light or the footpath and so on.
So I guess, government should take over and we should not have these rotation policies.
No, I have a thing. So one of my first projects was in Indore, and the IAS officers keep getting shifted every 3 years. So when we were trying to get into the project, and most of our projects struggle on the second set of people, not on the first set of people. So I was pretty much against it. But there was a government employee who retired. He said, see, if the guy is bad, and if he's stuck there for the next how many ever years, that creates more challenges than if the guy is good and he moves out, because the government takes care of itself. But when the guy is bad and he knows that he can't be moved, that creates a lot more challenges. So, and I don't have an answer for that. Okay, I know we are not talking AI and ML. Sorry about that. But these are all things for you to succeed, right? You need to understand where are the challenges and what is there. So from that perspective, I just want to add that.
There are some requests from corporates. AIML for HR, they wanted help in identifying, the right person for the right job. So maybe there is an opportunity for AIML even there. Any thoughts on maintenance and costs, not only of capital but also of maintenance?
I think most of it has been said. It might just be repetitive. And of course, as I said, in academics we don't really care for. We just give a design and say, now it's your problem, like a like a UG or a PG product, it just has to work on the day of presentation, right? And then next day it shouldn't work or something. So I think we are not, we don't also guilty from the academic side of not really focusing on that aspects of, therefore the things of reliability, resilience and all have been talked about, that self-healing and all those fancy terms which are used in market now. So okay, I don't have much to say, because we don't deal on that on a day-to-day basis.
Okay, fair enough. So I think we'll go to the audience now. I had a few more questions, but I thought I was seeing a couple of people dozing off. Right, so maybe we'll go to the audience and then we'll come back for final thoughts.
Well, somebody has to speak up for AI, right?
Who else but me?
So, no, I mean, I completely agree with almost all the points that were made, right? So I disagree with what Ramakrishna said. Finally, that's why I had to put my hand up. It's not that academicians are not worried about it, right? So there are a lot of work that's actually being done on things like model maintenance, integrity, performance guarantees, and a variety of things. But I still say that, there is this one classification of problems which people call them as wicked problems and easy problems. I'm pretty sure you are aware of that, right? So wicked problems are those for which you don't even know what an answer will look like, right? And most of the things that you are talking about today, right, in terms of actually adopting any technology into smart cities, forget about AIML, right? Any technologies in a more systematic way into large-scale projects that are happening, right? They're all wicked problems. Because we really don't have any answers to those. We don't know what the solution will look like, right? And what the academicians are good at is solving easy problems. However hard the optimization techniques, whatever it is that you put in, right? I mean, it might take you 10 years to solve the problem, but at least you know what the answer looks like, right? And I think when a technology advances to a point where you can start thinking about applying it to wicked problems, it's when that you feel this sense of where are we going with this? We can't do anything about it. And I'm happy to see that after the 80s, again we are back at a point where we are actually talking about applying AIML to these kind of wicked problems. And we don't have answers yet, I agree with you, but I don't think the answers are like decades away either, right? And at least on behalf of RBCDSAI, we'll be very happy to work with this, and we can set up like a joint working group between us and the Smart City Corporation. Then we can start looking at these problems, right? So I think that's the way forward. And like again, to say that AIML does not have the solution to all the problems that they're looking at, and I don't think we need solutions to all the problems that you're looking at need to come from AIML. In fact, when I'm talking to some of the MSMEs, right? So because RBCDSAI also has a very strong presence in industrial analytics and things like that. And I'm really shocked to find that most people don't even have a proper digitalization of their workflow, right? Forget about doing AML, like you're saying data, right? We don't have a way of gathering data. And in some cases, there are vendors who have sold data gathering machines to them. And in fact, the companies don't even know what data is being gathered and where it is stored. It's serious. I mean, we have actually spoken to companies. We say that we bought this product from this vendor, but we don't know what it is doing in our system. Somehow they managed to get these things installed. So I think a lot of conversations need to happen. We are doing it in certain verticals. We certainly have to do in the smart cities as well.
Thanks, Ravi, for speaking.
I actually found this quite a refreshingly candid conversation and panel. So I think thanks for having a professor play devil's advocate was a little bit of a refreshing change with a nice sense of humor. Two questions, I guess both kind of like focused at you, Raj. First is, wouldn't half the problems around things like the water issue be solved by having a cost and a price for water? Because that seems to be one of the key things that we're all waiting for. Most developed parts of the world have started fixing it. Do we even know what the cost for water is? I'm sure you may have a feel for it. So that's question one. And the second one is, in your opinion, when will we become carbon neutral in Chennai city?
So the first thing, see, my earlier NGO I used to do a lot of work on market-based systems and so on. So I'm a big fan of pricing, right? But the question is not simply about pricing. It's also a question of how do you structure the, let's say take Metro Water. Okay, I don't speak for Metro Water, I'm just an example. There are democratic principles, right? You want a poor person to be able to have free and clean and healthy water. The person who's watering his lawn or washing his Mercedes-Benz to pay for water, isn't it? But when the markets don't function and the policies are not there, you get this for 20 bucks, whereas the guy washing his Mercedes-Benz gets it for 0 rupees. So there is a market failure and a policy failure. So that cannot be solved with technology. Then also, for example, I got a lot of activist friends. I used to be an activist. So people, when they talk about pricing, immediately what they say is that now you're going to charge all the poor people even a drop of water. You're going to charge them and and give the water to this rich guy, and he'll start controlling the water. That's not what you mean by pricing, right? Operationalizing, privatizing or semi-privatizing the operations, keeping democratic control over water, it's a political problem, not a technology problem. Same thing with buses, for example. I mean, there are a lot of students here. So use this principle in all the systems you see, right? So imagine this is a bus company. A bus company was created. They're supposed to, it's a common company. It's supposed to run on profit and loss, right? But government democratically says, look, all the people over here should be given free ticket. It's a good thing, okay? For public transport, for example, or Tamil Nadu government's idea of women traveling free. I'm a big supporter of it. But that's not this bus company's problem. That's a government problem. Our systems need to be able to say, look, I'll hold this company accountable for the efficiencies of the company. I'll compare you to Bangalore, London, Paris, and say, you better, for 1 liter diesel, you better go X kilometers. Why are you not doing it? And then so on and so forth, as a part of Companies Act and so on. The laws, so-called laws being made in water, transport, and all the public good stuff is government and democracy and people's and taxpayers' problem. It's not the company's problem. When you flip it over and make it the company's problem, company is perennially at a loss. So the company says, look, I have no money. How can I give you bus service? How can I give you water service? So good cities would have got this separation of power, or whatever you want to call it, correctly. Unfunctioning or non-functioning cities would miss up the thing. You'll say it's your loss is your loss, policies on this side. So my point is, it's a political, policy issue, not a technology issue. What was the second question? I forgot.
Yeah, sense of net neutral for Chennai
so
city.
yeah, okay. Again, I can't predict. But again, we are at a very good point. As we speak, C40, which is a global city network, we are probably one of the few cities in the world probably that has a climate change, climate action plan already prepared. It's done, right? And Tamil Nadu government has a lot of progressive policies on greenhouse gas and so on. So if any city in India, Chennai has the best possible chance of moving towards carbon neutral and so on. So for example, whether it's electric buses, getting the wind and solar right, and a lot of other things like taking in many of our projects, whether it's footpath or whatever else, maybe LED conversion and so on. In many of these things, I think we are far ahead of many other cities. I can't give you exact dates. So simple example, I'll finish with this. We are actually trying to do carbon trading in smart city, Chennai Corporation. And from garbage disposal to LED conversion to all kinds of other things, we could be actually making money, in theory at least. Believe it or not, Chennai, every street light you see is an LED light, right? The amount of carbon that we have saved is unbelievable. Any other city in the world would have told everybody in the world, if London had changed one LED, they would have told that, we've saved the world because we've changed lakhs of lights into LED. So what is good and bad is that? Good is that a lot of good things happening. The bad part is it's all diffused and all over the place. So without giving you an exact date, I think we are at a very good position. Again, I'm requesting academics and others to jump in and see how you can help us. A lot of strategic pieces are in place. It's a question of just putting it together and taking it forward.
So I'm basically from a diploma institution. First of all, I request apologies for having interrupted during the discussion by the panel members. My point and question is regarding the manpower development for this AL and ML. Few years back, CCTV installation is a very difficult one. Now a normal electrician, basic electrician is doing CC2 installation. Similarly, an IoT project is done by school students and diploma students after the arrival of Arduino, some like things. But this AI and ML, even though the policy makers like the government and IIT professors, they are doing some algorithms or those things. When it will come to the lower end, because nowadays Google, AWS and Microsoft are giving AI as a service. Why can't you have some curriculum, simple curriculum to use this AI and ML to the lower level? A diploma student or some arts college students can develop this application of AI and ML, because we have to capacity building is required now itself. 20 years back, when IT programming are very complex, some private training schools are coming, NIT, AppTech, they are coming, they are taking classes. Then suddenly the IT boom up in India. Like that, is there any possibility of designing a curriculum using AI and ML like AI as a service in diploma level courses or some certificate level courses? This is my point and question, sir. Thank you.
Yes, I think the best person to answer is Prof. Ravi. Yeah. So at the diploma level, I don't understand why you have to say at the diploma level. In fact, we have started offering courses for AI ML even for students who are plus 2. See, that is already available, sir. So that is one part of it. The second part of it, I believe that even the Board of Apprenticeship Training started to do something on AI ML as apprenticeship programs also. So that is the second thing that is coming up. And the third thing is, I think very recently the Tamil Nadu government launched this thing, right? Nanum Mudalvan Dhan. Yeah. Nanum Mudalvan Dhan அப்படினு சொல்லிட்டு Tamil Nadu government has launched this program for training at all levels for upskilling. So this was launched just yesterday by the Chief Minister. You can look at those programs also. Lots of things are available. Mostly everything is available online now. Okay, sir.
Good afternoon, panels. My name is Sedibadi, retired from Qatar Petroleums. For 3 decades I worked. The question is to Mr. Raj. The NEET assessments for 497 locations, Chennai, only for Chennai or the rural like Karaikudi, Tanjavur, Tiruchi, etc. Number 1. Number 2, I support this AI and ML. In the 1991, when I went to Qatar, state of Qatar, there was no UPI, Google Pay, etc. Today, because of AI and ML, the financial tech has been improved. For I support the AI and ML. Thank you. We cannot.
I think Vijay is better qualified to answer this, but anyway, you asked me. So you have city limit and you have something called the Chennai metropolitan area, which is how many square kilometers? 1089 or something, right? Yeah. So we have looked at all the 300 odd junctions that police gave us, and his team as consultants looked at further junctions which need lights. So the principles they've used is again, how do you make traffic flow better? How do you give, let's say, 3-4 junctions flow happen, and then 5th junction you may stop for some time, and so on. Optimization that do in every city. So 400 and something is for the entire Chennai metropolitan area, and it's only in this region, not Karaikudi, not any other city. But the good news is, I think government is, as we speak, considering Coimbatore and other cities to kind of replicate the same kind of ITS system over there also.
They're doing Madurai and Coimbatore also. So basically there's a lot of interest in a ITMS project because traffic is a big problem. And even if you look at the smart cities, more than 50% of the cities have mobility as one of the key problems. So they had this PAN city and area-wide improvements in smart cities. The PAN city is what is the problem across PAN city. So out of these 100 cities, almost like 50 or 60 cities have taken mobility as one of the big challenges. And whenever you talk about mobility as a big challenge, the things that you're talking almost always are, you're talking about bus service, because metro by itself is not viable in most places, right? Most of these our tier 2 cities, they're not viable. Even in the tier 1 cities, they don't really pay for their operations. So you are spending money on your metro. So you look at it as economic value and you put it in, but you don't want to spend money unnecessarily.
Why I mentioned Karaikudi is a delta district affected by storm and catastrophic. Or the present government considering those areas where there is a catastrophic storm and rain, those kind of a information, digital information,
Yeah.
smart city can be improved?
See, I don't know about this, but on an average, what we are seeing in the last 5 years, okay, is everything is being looked at. Like that's the reason initially it was 20 smart cities, it became 100. Even each and every state, like there are cities that are not BJP states, they didn't want to get into the smart city program. So they created their own programs and actually moved ahead of the smart city programs. So I'm quite confident that this also, like at least in Odisha and stuff, we see Puri and others, they're looking at the disaster relief, flood relief and all that. So I'm confident that they're looking at it, but I don't know the answer for that personally because I'm not from Tamil Nadu.
Yeah, as Coimbatore and Madurai and all, A3, A2, A1 tier cities.
Yeah, yeah.
Whereas Karaikudi, Tanjavur and all, not that comes under the category. Thank you.
Yeah.
I think the smart cities was for the larger cities, and then they had other programs for the smaller towns. Yes. So I think it will come. I think it's a question of trickle down effect, right? Okay. Other questions, comments from audience? Sure, sure.
So a question for you, because you said you are from the power sector, right? One of the big challenges we have, like we were doing the technology project, adaptive control system project in Hyderabad, is the power fluctuations. Because when you have a certain amount of money as a system integrator, you cannot really spend money on highest quality of systems, right? But the LEDs and everything keep failing because Hyderabad, for some reason, the voltage is always 240 to 260 volts, okay? Always. And the systems cannot be really designed for that at the cost that they want to spend. Any reason why we cannot make it consistent? Like, is there anything? Because when we talked to our client, there was actually the electrical department of GHMC, the municipal corporation. They don't give us an answer. And in IIT Delhi now, I keep talking to the faculty members and trying to say that, hey, this is the problem I want solved. Okay, this is the problem which is creating most of the problems in India. Is this power surges, where if we can control the power surges, we can actually don't have to design, we design idiotic systems, honestly, to take care of the power surges, okay? So what, I don't know if you are the right, like I know expertise matters, but what is that we can do in terms of power surges and controlling this in our cities? Because that has been a critical issue and increases the cost of everything, okay, because of that.
Yeah, okay, I'm not a power engineer, but okay, I have some peripheral interest, like, you know, because this, as research is multidisciplinary, so, you know, you kind of try to look at problems which fit your, you know, expertise in different. So I don't know much on this, but the thing that could happen is because of the demand. This is demand surge. Right? This is not like a power surge, and then the standard load flow would suggest of why the frequency drops. I think this could be more from, and this demand can be predicted. It's kind of obvious when you are in summer here. You actually would know what time the voltage would fluctuate, and I'm sure the grid managers would also know these things. Just that I think they may not have enough. I'm just my guess. In fact, some of the problems also they solve is like this. So. About phasor measurements and all, right? Where they talk of placing of PMUs essentially to stabilize the grid.
We have PMUs, but the problem with that is it still cannot take up 260 volt all of a sudden, right? Even the PMU that you design for is designed at a particular thing, like the surge comes all of a sudden, like there's a time, because it comes down to the PMU cost also. If you wanted to take everything, the PMU cost will be a couple of lakhs. We don't want to spend that much. As system integrators, they don't pay us enough. We are making a profit-making company. That's what I want people to realize is once you are a system integrator, now I am not, now I don't care, but at that point of time, you are looking at the profit and you need to make some money. So if you are putting, that's my question is, we have power management units at every junction. So we are doing at about 500 junctions. At 500 junctions, we put power management here. So it takes care of most of the problems. It doesn't take care of about 10% of the problems, which still happens once a month. At one junction it happens, the whole junction goes away. And it's a safety concern, right? Any signaling system is a safety concern. So is the only solution to put this high-end PMUs at each and every junction, or is there anything that can be done at the source where we can fix this problem? Because at that point of time, I would think the AIML can come into picture to guess what you can do and try to fix that issue so that the power is consistent, so I don't even have to put a PMU there. because we are spending 500 and then we are putting systems into LEDs, we are putting something else into the solar panels. The number of things we take care of just because of the surges is crazy. Okay, so
the continuing on the thing with PMUs, I was, one of the problems was maybe so Sridhar works on is optimal placement of sensors, right? So optimal placement of PMUs. Then they'll come to academics for getting optimal locations. But it turns out that if you just put PMUs everywhere, you may not need more than 3,000 or 4,000, and you multiply by the PMU cost. It's not that much. Just that what happens once you have the PMUs and where you act on it, that's where I think you need to go to somewhere else, and that person maybe you can't maybe schedule your demand side response. So most of or the generation side thing control is very less. If you look at all smart grid papers and all, they mostly look at controlling the demand side, but nobody really talks of any, or maybe it's not possible, I don't know. So demand side you can regulate by, they call this ancillary services. They we do is islanding, right? So just to control searches. But there are things where you can, the grid manager can switch off your not very necessary appliances and so on. So much of things go on the demand side, and that's more reactive than proactive. So the supply side is something which nobody touches on, and I don't know why, because maybe that it's not easy to schedule supplies based on sudden surge at 8:30 p.m. And it stabilizes. If you look at it, doesn't really go from 230 to 180 and stay at 180. It's just that little transient, and for a lot of critical equipments, that is a big transient. Like a drop of, I think in India the variation of frequency is like 48 to 52, whereas in US it's like maybe they work at 60 hertz, so it's like they just allow a variation of 0.2 hertz. So I wouldn't know why the supply versus the demand side. Professor Sarup is not here. Maybe their students can answer something.
Maybe we'll take that during the break.
So most are I'm pushing IIT Delhi also, but this is a solution that is badly. So but all the solutions are more controlling the demand, not really regulating the supply. I
never faced a search problem. Probably in 14 years, probably once we heard of it. In India, it's been
I agree. So, but again, US they use, let's say perhaps they use 110, right? They don't use 220. So that also matters, I heard. Okay, so I think there's a couple of quick things. Is it? There's one here. Yeah, we need to close, but maybe.
This was a question I had for the Santishwar sir also when he was presenting. So when we look at city as a smart city, it's just about the IoT and connecting the devices, or we are actually looking at greener solutions for the power is also part of.
Somebody pointed out it's about livability, okay, and credit goes to the smart city mission, because when this thing in 2016, I was one of the biggest skeptics of this idea of smart city, because I figured it'll be all about IoT device and computer and cloud. If you look at the indices that they're measuring, you will never see the word technology there. It's about walking, cycling, clean water, clean air, public space. So we should, as a city, I'm talking about smart city AI only because it's a conference on AI. Otherwise, to talk about AI. But let's focus on the basics, right? Sir pointed out about education and skilling, for example. What's the point of having AI if nobody's unskilled and so on? So most of the things about smart city should be about simple green, and with respect to climate change and all, we should be moving towards cleaner and greener energy and all that. So all that is understood. The point I was trying to make originally is that how do we make that leapfrog without having to go through every step, right? How do we go from where we are to whatever other advanced cities, including Indian advanced technologies and stuff we're doing? That's where AI and everything else comes in.
Okay, thank you. So I had a question for Ramakrishna. So imagine that with the existing power generation sources like hydro and the thermal power plants we are running here, if we add the other power generation sources, which are the renewable ones like solar or wind, are there any things in terms of handling the data or analyzing the data when these new components are included into the system? Is it going to be more technically challenging, or the scale of problems that we are working would be on the same scale if you wanted to use AI or ML on these things? I hope my question is not too long. And
The question is not too long. I don't think I quite understand the question.
Okay, so
the integration of renewables with non-renewables.
Correct. Would it lead to more complicated complications in terms of analysis of data and so on?
It's not complicated. It's like how do you manage? So you will have say cloud cover. You know, what will you do with your solar generation? You have little fluctuations in wind. I think all this have been studied well and documented well of how people ensure still supply or again what you're worried about is load voltage and frequency, right? And from the supply level. And these things have been documented well. We can do that. Maybe I can share you some resources on that.
It's less of a question and more of a point. So, yeah. So I agree with Raj in the sense that AI has been hyped to the extent, right, where people like Raj are initially dismissive of AI. No, I agree. I mean, the AI fatigue is actually fairly understandable, right? So when people come to me, when they actually ask for solutions and say, oh, we want to use AI and things like that, first thing I tell them is, okay, let's understand your problem. Get a working solution. AI is value add on it, right? If you say that you need the AI to actually even solve the problem, maybe you're going about doing it the wrong way. I think that's an approach we should take, and we should not, off the bat, dismiss saying that AI, ML doesn't have a place in smart cities and things like that. Just my take on it. So that's
sure. So I think we are out of time. Any final thoughts from any of the panelists? Particularly, I had one question about, I mean, expectations keep going up, right? How do we make ourselves prepared to meet the expectations of the future, right? So being smart is about anticipating what is to come and then placing ourselves, at a place where we are solving future questions, right? So how do we get there? Any thoughts related to that or otherwise?
I don't think you should be concerned. We have the students here who will take off the future, right? So we don't have to do anything. So yeah, so the expectation is, see, again, the reason we are talking, Raj and I, is please think in terms of what you're trying to achieve. All these are things to a means, right? So you got to think about AI and ML or anything as a value add, as rightly pictured out, to solve a problem that is already solvable but very, very difficult to solve, using this to make it more sensible. Like my PhD was genetic algorithm based optimization, hill climbing and other things. If you know the other optimization methods, they are very, very complicated. They don't get to the near optimal. Genetic algorithms at that point wasn't even considered AI. Okay. Now afterwards, after 15 years, I keep hearing it as AI and all that. At that point, I don't know what it was considered. I thought it was biology, to be honest. But so the thinking process is always the same, right? The thinking process is every few years people will come with a new keyword, right? In another 5 years, there will be a new keyword which might be the same thing as AI and ML, but it will be called slightly different. That is what is smart cities, honestly. It is not something new. It is BJP's own keyword because they didn't want to use whatever Congress was using and vice versa, right? And if you see US federal highway government, if you look at the research projects that come on, we used to call these IVHS, then ITS, then connected vehicles, then V2X, right? So you look at it, they change the words so that there's a new excitement, new energy into it. So there's nothing wrong with it, okay? But it is a usage, it's a term, but we are trying to finally solve the city's problems, the country's problems, and that's how we need to think about it.
I think I'll just make an offer that, so the last 6 years, what we've been trying to do is, we asked ourselves, what if Chennai were a sandbox? So we said, okay, we can't give you money because every rupee, it'll be paperwork and all that, right? What I found is that most startups and so on have money, but they want some permissions, data. They'll claim that, this magic thing will do something. We need to be able to place it here and give us sewage, give us bad air, so we can show you how it works and so on, right? It seemed to be a very difficult process. We've not been able to do anything, even though we've been very forthcoming and hundreds of startups came to us. Some of that match never happened, right? Once in a while something happens, but it didn't fall into place where it's like a factory, things happening. So what I would love to see happen after this conference would be, can we, both answering your futuristic question plus the near future questions, right? Can we take 2-3 interesting problems that the commissioner of the city or engineers of the city or public of the city is trying to solve, and we will do our best to give you as much data and whatever else that you will need. Let's see if we can solve some of those problems, and also ask some of those advanced questions, right? Like the pothole question. Fix standard problems using data and so on. We are more than happy to help, and let's also see if we can pull in the Tangentco people for the electricity, pull in the water people, and so on and so forth, the police and so on. We can try to have a get together sometime soon and try to identify, let's say, top 10, 15, 20 problems and see how students and others can help us solve it. Yeah. Okay, I think we'll wrap up. Over to you, Siddhartha. Thank you so much.
All right. I thank the panelists for the very candid discussion. I'm sure the audience had a lot to take away from this discussion. I invite Professor Balraman Ravindran onto the stage to hand over mementos to the panelists. Mr. Raj Cherubal. With that, we're done with all our events here. I call upon Professor Sridharakumar Narasimhan to convey a word of thanks.
Deja vu all over again. First, let me thank, let's start backwards. Let's thank the panelists and Raj for chairing the panel and Geeta for moderating it, and all the speakers for spending time. Thank the audience and the participants. Thank the people who have come up to demonstrate their wares and stuff. And we will be announcing the stalls. Right? So Siddharth will, after I'm done, Siddharth will announce when and where the stalls are being put up. Thank the organizing team. I know it's a long list, so I don't want to miss out any names. So just I'll ask all of you to join me in thanking the organizing team from RBC, from IIT, from ICSR for making this event a grand success. Also, the caterers. So we had food for. This is a joke that I keep going every time, every place. So we had food for thought, and for the palate. And is there anybody I missed? If there's anybody I missed, it's all my fault. And thanks to you all again, once again, and hand over the floor to Siddharth again.
Thank you so much, sir. Before we disperse, I request everyone to rise for the national anthem.
भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जनगण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे